NEC section 334.102 allows the white wire in MC cable to be used as an ungrounded conductor. However, there's a crucial stipulation: it must be permanently re-identified at all visible and accessible points. This re-identification is achieved through marking or attaching tags. NEC section 310.15b6 addresses the use of wires as equipment grounding conductors. Specifically, it prohibits the use of wires smaller than number 6 as equipment grounding conductors. However, NEC section 310.15b7 permits the use of wires smaller than number 6 as ungrounded conductors. Given the code references, using 10/3 MC cable for a 3-phase 240-volt condenser bank is permissible, even if the white wire is used as an ungrounded conductor. The phasing of the conductors is also acceptable based on the NEC. The concern about using the white wire as an ungrounded conductor likely stems from older practices or misunderstandings of current code. Always rely on the actual code language from the National Electrical Code or reputable sources to guarantee compliance. When using the white wire as an ungrounded conductor, permanently re-identify it at every visible and accessible location. This can be done with colored tape, paint, or specifically designed marker tags. The re-identification must clearly indicate that the wire is now a hot conductor and not a neutral. Ensure the marking is durable and resistant to environmental factors. For a 3-phase 240-volt system, you'll have 3 hot conductors and potentially a ground. The 10/3 MC cable typically contains 3 conductors: a black, a red, and a white wire, plus a ground. The black and red wires are readily usable as hot conductors. The white wire, after proper re-identification, can serve as the 3rd hot conductor. Remember that while NEC section 310.13b7 allows smaller wires as ungrounded conductors, always verify the ampacity of the number 10 wire is sufficient for the 20 to 25 amp load of the air conditioner condensers. NEC table 310.16 provides ampacity ratings for conductors based on insulation type and temperature rating. Also, consider any derating factors for ambient temperature or conduit fill, as outlined in NEC section 310.15c. Using MC cable offers mechanical protection for the conductors, making it suitable for exposed or concealed locations. Secure the MC cable properly using appropriate connectors and supports, following NEC Article 330 guidelines. The connectors must be listed for use with MC cable and sized correctly for the cable diameter. Support should be installed at intervals specified in the NEC, typically every 6 feet. Check the voltage drop. Voltage drop can affect the performance and lifespan of electrical equipment. Calculate the voltage drop for the length of the MC cable run to ensure it remains within acceptable limits, as recommended by the NEC. If the voltage drop is excessive, consider using a larger conductor size or shortening the run. When making connections to the air conditioner condensers, use appropriately sized and listed connectors. Ensure the connections are tight and secure to prevent overheating and arcing. Follow the manufacturer's instructions for connecting the conductors to the equipment terminals. If the equipment requires specific torque values for the terminals, use a calibrated torque wrench to tighten the connections to the specified torque. Grounding is critical for electrical safety. Ensure the equipment grounding conductor in the MC cable is properly connected to the equipment grounding terminals at both the source and the load. The grounding conductor provides a low impedance path for fault current, helping to protect against electrical shock. If the MC cable is installed in a wet or damp location, use connectors and fittings listed for wet locations. These fittings are designed to prevent moisture from entering the cable and equipment enclosures. Consider using a sealant or washproof tape to further protect connections from moisture. When pulling the MC cable, avoid kinking or damaging the cable. Use cable pulling lubricant to reduce friction and make pulling easier. Do not exceed the maximum pulling tension specified by the cable manufacturer. If the cable run involves multiple bends, use a larger conduit or junction box to facilitate pulling and avoid damaging the cable. Before energizing the circuit, thoroughly test the installation. Use a multimeter to verify the voltage, continuity, and insulation resistance of the conductors. Check for any unintentional grounds or shorts. Perform an insulation resistance test to ensure the insulation is intact and there are no leakage currents. After energizing the circuit, monitor the equipment for proper operation. Check the voltage and current at the equipment terminals to ensure they are within the specified ranges. Listen for any unusual noises or vibrations that may indicate a problem. If any issues are detected, energize the circuit and investigate the cause. Consider adding overcurrent protection. Overcurrent protection devices, such as circuit breakers or fuses, protect the conductors and equipment from overloads and short circuits. Size the overcurrent protection device according to the ampacity of the conductors and the requirements of the equipment. The overcurrent protection device should be readily accessible and clearly labeled. When working with electrical systems, always follow lockout-tagout procedures. Before working on any electrical equipment, de-energize the circuit and lock out the disconnecting means. Tag the disconnecting means to indicate that the circuit is being worked on and should not be energized. This helps to prevent accidental energization of the circuit and protects workers from electrical shock. Adhere to all applicable safety regulations and guidelines. Electrical work can be dangerous if not performed properly. Follow all applicable safety regulations and guidelines, including the National Electrical Code, OSHA regulations, and company safety policies. Wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. If you are not qualified to perform electrical work, hire a licensed electrician. Remember that electrical codes and regulations can vary depending on the jurisdiction. Check with your local electrical inspector or building department to ensure that your installation complies with all applicable codes and regulations. Keep accurate records of the installation, including the cable size, length, and routing. This information can be helpful for future maintenance and troubleshooting. Label all circuits and equipment clearly. This helps to identify the circuits and equipment and makes it easier to perform maintenance and troubleshooting. Conduct periodic inspections of the electrical system. Inspect the electrical system regularly to identify any potential problems, such as loose connections, damaged conductors, or corroded equipment. Address any issues promptly to prevent more serious problems from developing. Stay up to date on the latest electrical codes and regulations. The electrical codes and regulations are constantly evolving. Stay up to date on the latest changes to ensure that your installations comply with the current requirements. Attend continuing education courses or seminars to learn about new technologies and best practices. Consider using energy-efficient equipment. When replacing or installing new electrical equipment, consider using energy-efficient models. Energy-efficient equipment can save money on electricity bills and reduce environmental impact. Look for equipment that is Energy Star certified. When using MC cable outdoors, select cable that is rated for outdoor use. Outdoor rated MC cable is designed to withstand exposure to sunlight, moisture, and other environmental factors. Use connectors and fittings that are also rated for outdoor use. Properly support the MC cable to prevent it from sagging or becoming damaged. Use cable ties or straps to secure the cable to supports. Avoid over-tightening the cable ties or straps, as this can damage the cable. When routing MC cable through walls or floors, use appropriate bushings or grommets to protect the cable from abrasion. The bushings or grommets should be sized correctly for the cable diameter and securely fastened to the wall or floor. When terminating MC cable in electrical boxes, use appropriate connectors to ensure a secure and reliable connection. The connectors should be sized correctly for the cable diameter and tightened to the manufacturer's specified torque. After terminating the MC cable, inspect the connections to ensure that they are tight and there are no exposed conductors. Use a multimeter to verify the continuity and insulation resistance of the conductors. When working with three-phase power, it is important to understand the phase rotation. Phase rotation is the order in which the three phases of the power supply reach their peak voltage. Incorrect phase rotation can cause motors to run backwards or not start at all. Use a phase rotation meter to verify the phase rotation before connecting any equipment. If the phase rotation is incorrect, swap two of the phase conductors to correct it. When installing MC cable in hazardous locations, follow the requirements of NEC Article 500. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Use MC cable and fittings that are specifically listed for use in hazardous locations. Ensure that all equipment installed in hazardous locations is properly rated and approved. When installing MC cable near sources of heat, use cable that is rated for high-temperature applications. High-temperature cable is designed to withstand the heat without degrading or melting. Maintain adequate clearance between the MC cable and the heat source. When installing MC cable near sources of electromagnetic interference, use cable that is shielded to reduce the effects of the interference. Shielded MC cable has a metallic shield that helps to block electromagnetic interference. Ground the shield properly to ensure its effectiveness. When installing MC cable in corrosive environments, use cable that is resistant to corrosion. Corrosion-resistant MC cable is made from materials that are not easily corroded by chemicals or moisture. Use connectors and fittings that are also corrosion-resistant. When installing MC cable in areas subject to vibration, use cable that is flexible and resistant to vibration. Flexible MC cable is designed to withstand the vibration without cracking or breaking. Secure the cable properly to prevent it from vibrating excessively. When installing MC cable in areas subject to physical damage, use cable that is protected by a conduit or other physical barrier. The conduit or barrier should be strong enough to withstand the expected physical damage. When installing MC cable underground, use cable that is specifically listed for underground use. Underground MC cable is designed to withstand the moisture and pressure of the soil. Install the cable in a trench and backfill with suitable material. Consider using a tracer wire to help locate the cable in the future. The NEC requires electrical work to be performed in a neat and workmanlike manner. This means that the installation should be clean, organized, and free from defect. The MC cable should be properly supported and secured, and the connections should be tight and reliable. All electrical boxes and enclosures should be properly labeled. When the white wire is re-identified as an ungrounded conductor, the color used for re-identification should be a color other than green, white, or gray. Common colors used for re-identification include black, red, and blue. The re-identification should be permanent and easily visible. Electrical systems should be inspected and tested regularly to ensure that they are operating safely and properly. The inspections and tests should be performed by a qualified electrician. Any problems or defects that are found should be corrected promptly. The use of MC cable can help to reduce the risk of electrical fires. MC cable is a durable and reliable wiring method that is resistant to physical damage and moisture. The metal armor of the MC cable provides a barrier against fire. When properly installed and maintained, MC cable can provide many years of reliable service.